Alright everybody, so today's video is going to be an introduction to limits. You may remember using limits when you were talking about end behavior last year, behavior around asymptotes, a few times in pre-calculus that we used limits, but really touched the surface of limits, and this year we are going to do a little deeper dive into them. So, first off, definition, a value. Let me get a good highlight here. Definition of a limit is a value a function approaches but does not reach. We will get very close to it, but we do not actually have to get there. Our notation. So we will write the limit, lim, as x. This arrow approaches a of f of x. And this is how it's said when we say it. We would say the limit as x approaches a of f of x is our notation there. Okay. We may see specific functions, so we may see something like this. This means the same thing. This is saying that a is the same thing as 2, and f of x is now 3x plus 5. Alright. A couple types of limits. So the first type of limit is a left-hand limit. And this is a value that a limit approaches from the left. And if you notice our notation, we've added this little negative sign here because the left side of the graph is the negative side of the graph. So we would say the limit as x approaches a from the left of f of x. So we're going to give an example and we're going to use the value at -3 here. So I'm going to draw this vertical dotted line to show you the direction that we're going. So if I wanted to write this limit, I would say the limit as x approaches -3 from the left of f of x. So I'm including that small negative sign there. And if I look at my graph, as I approach -3, the value we're approaching, and when we say value up here, we mean y value. The value that we're approaching, I'm getting closer and closer to, is actually -2. So we would say that the limit is -2. The left-hand limit is -2. Even though we don't get there, that's the value we're approaching. Alright. Up next we have the opposite direction. We have the right-hand limit. So a value that a limit approaches from the right. You'll notice that our notation changes a little bit, that we've added this plus sign. That's because we're approaching from the right side of the graph. So if I wanted to write the right-hand limit as x approaches -3 of f of x. So if I look at my graph here, as I approach that point from the right, we'll see that the y value we're approaching is +1. So we're going to say that that limit is equal to +1. Alright, last we have our general limit. And the notation that we learned at the beginning, that is our general limit with no symbols after. But the unique thing about the general limit is that the general limit only exists when the left-hand limit is equal to the right-hand limit. Okay. So you'll notice in this case, at -3, the general limit would not exist because the left-hand limit equals 2 and the right-hand limit equals 1. But we'll also look at another example of a limit. And so we're going to use the value x equals 4. So we're going to start with the left-hand limit as x approaches positive 4. So as x approaches 4 from the left. So if I draw my arrow here, I notice the y value I'm approaching is positive 6. So I can say that that limit is equal to positive 6. Now I'm going to look at my right-hand limit as we approach 4 from the right. So as I approach 4 from the right, notice that the y value I'm approaching is positive 2. Alright, so I have my left-hand limit equals 6, my right-hand limit equals 2. Got ahead of myself there. Shouldn't have put that, sorry. Anyways, since we have a situation where the left-hand limit and the right-hand limit are different, we are going to say that the general limit does not exist, DNE, because it only exists when those two things are equal. Lastly, we can try and evaluate at x equals 4. And if you notice, since both of these are open circles here, that f of 4 is undefined. And we had a problem like this on our previous problem set. Okay? Alright, so I'm going to take a pause there, and we are going to do 2 quick examples, and I will let you go. So the first example, we're going to start with, what does this look like at a continuous point? So remember, continuous means I can draw it without lifting up my pencil. And the continuous point that I'm going to choose is at x equals 7. So let's start with our left-hand limit. So x approaches 7 from the left. And as we approach 7 from the left, notice that the y value we're approaching is negative 2. So I can say that the value of the limit is negative 2. Let's do our right-hand limit. And if I look at my right-hand limit, I also notice that the y value I'm approaching is negative 2. So we said earlier that the general limit only exists when those two limits are equal, the left hand and the right hand. Therefore, since this is negative 2 and this is negative 2, my general limit exists. We also see that because it's continuous, f of 7 is also equal to negative 2. Alright, let's look at a discontinuous point. And the discontinuous point that we are going to look at this time is when x equals 1. So let's start with our left-hand limit. Our limit, gotta change up the pen there. Sorry. So our left-hand limit, our limit as x approaches 1 from the left. Alright, as we approach 1 from the left, it looks like the y value we're approaching is positive 5. So I can say that that is positive 5. Alright, how about my limit from the right? my limit from the right. Looks like it's also approaching positive 5. So we said earlier, these two things are the same. Therefore, limit as x approaches 1 equals 5. Now we did say this is a discontinuous point. Discontinuous means I have to pick up my pencil to complete that graph. So why is it discontinuous? Well, there is a hole here, but the point is defined down here. So if I were to ask you what is the value of f of 1, we would say 3, because that is where I have the closed dot. And the reason this is discontinuous is because those two things are different. My limit does not equal my value at the point. Okay? We are going to get into that conversation a little later. So this is a brief introduction to some limits. This is just looking at them graphically and getting some notation. All right? And I will see you all on Tuesday.